Hello and welcome to Lab Talk. Today we have a treat for you. We are talking about sample organization. My name is Angela Carnwright. I'll be your host today. I'm with the marketing team here at Thermo Fisher Scientific, and we are so pleased to bring you Lab Talk. This is a series of tips and skills that we can use to ensure that you have a great experience in the lab, provide some efficiencies and best practices to help you get to your discoveries quicker. So today we have Anshula Sharma. She is our commercial manager here for our storage products, and she has lots and lots of experience and some great tips for us today. So I'm going to hand it over to Anshula. Over to you, Anshula. Thanks for coming.
Welcome, everybody, and thank you. So today, let's talk a little bit about sample accessioning, what that means, and some of the methods that are out there currently and what may work better for you depending on your lab needs. So what is sample accessioning? So sample accessioning refers to the process of receiving and documenting samples in a lab or a research facility. It involves assigning a unique identifier or an accession number to each sample, recording the relevant information about that sample, and then ensuring proper storage and tracking. So the purpose of sample accessioning is to establish a systematic and an organized process for receiving, documenting, tracking those samples in a lab or a research facility. So let's take a look at some of the steps here. So first we have the sample identification. Assigning a unique identifier or an accession number to each sample ensures that it can be easily identified, right, and distinguished from other samples. And this unique identifier serves as a reference point for all of the subsequent sample-related activities. Then you have data documentation. So it's not just the physical sample itself, it's all of the information that surrounds or comes with that sample. So accurately recording that relevant information, such as the sample type, the source, the date, the storage location, ensures that all the crucial details are also captured and documented for future reference. So this information is essential for maintaining data integrity, traceability, and reproducibility for all the experiments that labs do, right? Then we also have a quality control component. So when you implement these protocols, they help to maintain a certain quality control by ensuring that samples are properly labeled, handled, and stored, and it so prevents mix-up of samples and any kind of errors that could happen during the process. And then we have sample tracking. So by tracking the movement or location of a sample, it allows for efficient retrieval, right? And also sharing that with other collaborators, maybe. So this enables researchers to quickly locate and access specific samples when needed, saving time and resources trying to hunt them down. And we also have a regulatory compliance piece. So proper sample accessioning practices support compliance with regulatory requirements, such as good laboratory practices or GLP, good manufacturing practices like GMP as well, and accreditation standards as well. So accurate documentation and traceability are crucial for audits, for inspections, and for demonstrating quality compliance with quality standards. So let's take a look at some of the methods that you might be using yourself or that you might be familiar with that different labs are using. So first we have the manual entry. Now this is very common for so many labs that are out there. So manual entry involves recording sample information such as the ID, the date, the description, storage location into a laboratory information management systems or LIMS, or a designated sample tracking spreadsheet. So this allows for flexibility, customization. You can capture all kinds of sample data according to your specific lab requirements. However, manual entry can be time-consuming and prone to human errors. It serves as a cost-effective option, though, for labs that may have limited resources or smaller sample volumes, right? And then we're looking at barcode or QR code scanning. So this is actually very common, and we see this being used in many labs. So each cryosample is assigned a unique barcode or a QR code, or already comes with the tubes coded. So you could have a 2D, a 1D, a human readable, which can easily be scanned using a barcode scanner or even a mobile device with scanning capabilities, right? So this barcode or QR code scan allows for, again, a quick and accurate data entry and retrieval. It reduces the chances of manual error, and it also enhances efficiency. Scanning technology also enables like quick identification when you need it. When you need to pull something out, you can easily get a quick read and know exactly what your sample is. So it helps with the tracking of the samples and obviously better sample management. Then we have RFID technology. So here samples can be equipped with a radio frequency identification, which is the RFID tag that contains unique identifiers. So they can be, RFID readers can automatically capture this information and track the sample data just by being in proximity to the tagged container itself. So this technology offers real-time automated data capture and tracking, which also reduces any kind of manual efforts, and it improves the accuracy and efficiency for maintaining your samples. This technology is also particularly useful for large-scale sample management, right? When you have a lot of samples to manage, this is actually a pretty nifty technology, where rapid and automated tracking is very essential when you go into those large volumes. And then we have the integrated LIMS, or the sample management software. This is more of software that integrates with other systems that you may be having in your lab, but I wanted to make sure that I call it out because it is integral to all of the automation processes. So this software provides a comprehensive solution for streamlining and sample accessioning processes, as I just mentioned. So these systems offer a feature like a barcode scanning, a data entry form, and sample tracking functionalities. So once something is integrated into the integrated LIMS, or the sample management software, it centralizes everything into one place, making it easy to access, easy to retrieve, and as well as sharing the data across the laboratory. So again, the system includes additional modules for sample tracking, inventory management. It enhances the overall lab efficiency. And then when we get into the very high throughput, where you have a lot of samples to manage, we have automated sample handling systems. So these laboratories utilize these systems that employ robotics and maybe some advanced technologies to manage sample inventory and perform various tasks related to accessioning. So that they can automatically label your samples, they can scan barcodes or the RFID tags, and store samples in designated locations. And once they're there, they can easily be retrieved from those locations. So they reduce a lot of the manual labor, they minimize error, they enhance workflow efficiency. As I mentioned, very useful for high throughput laboratories and those dealing with large sample volumes. And these systems, of course, can be integrated with the LIMS or sample management software to ensure seamless data flow and real-time sampling tracking as well. So by considering some of these different methods for sample accessioning, labs can choose an approach that best suit their needs, right? Resources and sample volumes. So you could implement efficient practices that are very relevant to your needs. So here, let's take a look at why would you choose one method over the other? So depending on the sample volume and throughput. So labs should assess the volume of samples they handle and the desired level of automation that they would need. So higher sample volumes may benefit for a more automation-friendly approach, like a barcode scanning or RFID technology, because that will reduce a lot of the human errors. And then depending on the budget and resources, this is also a very critical factor. Labs need to evaluate their available budget and resources. Manual entry or barcode scanning methods may be more cost-effective for labs with limited budgets, while automation systems may require higher investment, right? Data accuracy and integrity. Labs should prioritize, of course, data accuracy and integrity. So methods that minimize the manual entry or human errors, such as barcode scanning or RFID technology, can enhance that accuracy and reduce the risk of any kind of sample mix-up or labeling. Then integration with existing systems. Labs should consider whether their method can be seamlessly integrated into existing LIMS systems or any kind of sample management software that they're working with. So this can actually streamline the workflow and enhance the traceability of the samples and improve overall lab efficiency. Then you have regulatory compliance that you might want to consider as well. So labs should ensure that the chosen method meets their regulatory requirements, industry standards as well. Especially in regulated environments like clinical or pharmaceutical settings, this becomes very important. And then we have scalability and future needs. So you need to consider your future needs as well, right? So methods that can accommodate increasing volumes, like automated systems or LIMS, can support the future growth. So if you are planning to grow, then you need to probably make a different decision. And of course, the need for frequent method changes. So you might want to consider that too if you're changing or increasing or increasing to more automation-friendly methods. And then we have user training and familiarity. So labs should assess the training required also for personnel to adopt and utilize the chosen method, right? Everybody needs to know how to use the method properly and efficiently. Methods that are user-friendly and familiar may result in a quicker adoption, of course, and a smoother implementation in that lab space. So by carefully considering these factors, you can select any method that optimizes sample management, enhances efficiency, and meets your specific requirements. So regular evaluation and adaptation of the method may vary as the lab needs grow over time and as they evolve. So with that, we're going to do something fun. We are going to go over to the immersive lab and take a look and see what Megan is up to. Hey, Megan.
Hey, Anshula.
Oh, I can hear you. How are you?
Hey, I'm great, but I'll be honest, I'm a little tired. You caught me, I'm just in the middle of getting ready to store some samples. So I've been labeling my tubes, writing my sample down in my notebook. But I feel like I've been at this all day. It's very repetitive. And I'll be honest, my handwriting is a little sloppy today. So I hope people can read this after I'm done.
I think we have a solution here, Megan, that might help you increase your productivity and make things a little bit easier for you. Not only you, let me say that, as well as for your lab mates. I know how hard it is to read other people's handwriting sometimes. So definitely we do have some options for you to look into. So we just saw Megan using a very manual process for sample labeling. So let's turn our attention to the presentation window and see how an automation setup would look like and see if we can help Megan out here.
So you are looking at the VisionMate HSX barcode reader, and we will see how quickly it can read all 96 tubes. So Megan's placed an entire rack of matrix tube on the reader, and within seconds, it has given a full read. If you take a look at the screen, you can see the green read, which shows that all of the 96 tubes have been read, and it is a complete read. From here, you can take all the data that you see for all of the barcodes and link that up to a LIMS system, which can then be stored as your database of tubes, and you know at all times what your samples are and where they are kept in the lab. And it was so quick to see that. So just including a little bit of automation into your workflow can save so much time and effort for all of the processes that you have currently for accessioning. Now let's take a look at how quickly an incomplete rack of tubes is read. So this is what happens on a day-to-day when you're working with samples in the lab. You may have an incomplete rack of tubes, samples you've used, sent, shared, collaborated with, and are no longer on the rack. And you can see that the barcode reader will read that as well, and it will give you an indication of the tubes showing if there are any missing, in which case, yes, there are. So it's a red signal that you see. So it's a red visual, just so that you know you don't have a complete rack of tubes. And this really helps in understanding how the samples are being utilized in the lab, where they are, what is left behind, so you can keep a complete record of entire racks of samples at all times with a little bit of automation, as I mentioned.
So with that, let's cut back to the immersive lab camera.
Wow, Anshula, thank you so much for helping me, take some manual steps out of my process. This was so much faster than what I was doing. So, I just scanned my rack of tubes, I exported my data, and now I'm ready to go store these in my ultra-low freezer.
Awesome. I'm so glad to see that you do have some options now to manage your samples, and you don't have to spend so much time, and we don't have to think about what was written on the side of that tube. So this is awesome. And it's as easy as that. All right, everyone. So we just saw Megan do an excellent demo in the immersive lab and how easy it was for her to manage all of those tubes all at once and scan them, record the data, and put them away. So the important thing here in summary is sample accessioning and the protocols that you use, the processes that you use, it really helps to be more efficient with the data entry. As we saw the two different methods of capturing the data and the differences between them. So when you introduce automation into your workflow, data entry becomes a little more efficient, more easier and streamlined. It's less prone to errors and confusing labels. You have enhanced organization, quick and accurate retrieval of samples. And when you need to share those samples, all of that data is captured and stored, right? So again, as we end, I want to say that efficient lab accessioning really does help ensure accurate tracking. It enhances data integrity and streamlines the lab operations for all kinds of labs. So with that, I'm going to pass it. Oh, here, we do have some resources here that should be available to everybody. If you want to take a look at the some of the storage solutions that we offer, you can find them here.